So firstly, it is the largest part of the hindbrain. And we know that the hindbrain is, the rhombencephalon, which was the pons in the cerebellum, and the medulla oblongata, so the metencephalon was the cerebellum and pons. It forms the roof of the fourth ventricle, with the upper half being superior medullary velum, and then the lower half being part of the vermis, and connected to the brain stem via these peduncles. Now specifically, the superior one is going to be connected to the midbrain and the closest to the thalamus as well, and the middle one to the pons, and the inferior one to medulla oblongata. It will lie underneath this dural fold, the tentorium cerebelli, in the posterior cranial fossa. That's where it lies. And it has ipsilateral connections to the body, so it doesn't really like the whole crossing over thing. So the same side is represented by its own side. And it has an anterior and posterior notch. The anterior notch is where, your brainstem will just like sit in conveniently. And now for its general functions. It is entirely motor and it's operating unconsciously, so only when things get to the neocortex can it be conscious. It's unconscious in the cerebellum. Balance, posture, and coordination of movement. And when we're talking about these functions, we will relate it just now to the anterior, posterior, and floccular nodular lobe, where we get there. And then for the external features, we have these folia as part of its its cortex. It has the two hemispheres connected by a vermis, and then if you look at it superiorly, the vermis is raised, but then inferiorly, the vermis is in the vallecula, so it's like a depression type thing, and falx cerebelli will be in that, forming this occipital sinus, which will run along that occipital crest, internal occipital crest, which runs from foramen magnum to the internal occipital protuberance. And then if we look at its external features, I spoke about the folia, and the vermis is divided into various parts. Lingular, central lobule, culmen, primary fissure between culmen and declive. Declive folium, between folium and tuber, horizontal fissure, which doesn't have a function. And then tuber, pyramid, uvula. And then the posterior lateral fissure separating this posterior lobe from the floccular nodular lobe. The vermal part of the floccular nodular lobe is obviously the nodule. And then, we have those three lobes. The anterior lobe, which is this, up until that fissure there. Posterior lobe, which is this entire thing here. And then the floccular nodular lobe, this little thing here. Posterior lateral fissure between this posterior lobe and the floccular nodular lobe. Primary fissure between posterior lobe and the anterior lobe. Okay, and they all have their functions. Here's the external features again, just showing you the vermis and the fact that there's a primary fissure and a posterior lateral fissure. And then it's horizontal fissure, which is useless. Okay. Now for the functions, we'll start with the floccular nodular lobe, which is also known as the vestibulocerebellum, which gives you a clue to its function. The fact that it's vestibulo means that it's going to be for balance, because we know, vestibular nuclei, balance, okay, balance and equilibrium, truncal coordination. The fact that it's doing truncal coordination means that it's going to be controlling those paraxial muscles, regulating them. So information is received from the reticular formation and from vestibular nuclei. They use the inferior cerebellar peduncle to get to this fastigial nucleus, which is in the midline, and information is sent back to the very same things via the inferior cerebellar peduncle again. And then I just named those specific tracts as well. And then because we know we're going to control paraxial muscles, or we're going to be sending information to paraxial muscles and receiving information from those muscles as well. If there's disorder of this lobe, it's going to affect that. It's going to give you truncal ataxia, a broad-based gait, because you want to lower your center of gravity to be able to steady yourself, because you sway when you stand and when you sit. So that's a floccular nodular lobe syndrome. Moving on to the anterior lobe, known as the spinocerebellum. Again, this other name for it is a clue to the tracts that are involved, the ventral and the dorsal spinocerebellar tracts. The ventral one uses the superior cerebellar peduncle. The dorsal one uses the inferior cerebellar peduncle. It will reach these nuclei. Now, in the video and the DH, damn, there's some confusion, okay? Because textbooks say one thing and then the video says something else. So I just included what the textbook said, which is global symboliform and fastigial nuclei being involved, and the fact that it projects to the red nucleus, which is in the midbrain. It has to use a superior cerebellar peduncle, because I mentioned earlier that the peduncles are connected conveniently. You know, you have the superior cerebellar peduncle connected to the midbrain, so if you want to get to the midbrain, you use this peduncle from those nuclei. So that's, you know, that's like an efferent pathway, and this is an afferent pathway. And again, up here, the afferent pathway and the efferent pathway. And all of these pathways to the cerebellum have to use peduncles, and we're going to use the most convenient one to get to wherever we need to go to, the red nucleus. And if we know from the extrapyramidal system, the rubrospinal tract is going to be involved with you know, coordination and tone and posture and stuff like that. So the anterior lobe coordinates limbs, and these are from your lower limbs. Spinocerebellar tracts also come from your upper limbs, the cuneo-cerebellar and the rostral spinocerebellar tract as well. Yeah, and the disorder of the anterior lobe would affect your limbs, as you can see. First in the lower limbs, and it may progress to the upper limbs. And if you want to test that, we do a heel-shin test, because that involves limbs. Okay, that's the spinocerebellum. So we've done vestibulocerebellum, spinocerebellum. Now we're going to move on to the neo, or the new cerebellum. And that's involved in skilled movements and motor planning. So the end goal would be to get to this place, the primary motor cortex. And motor planning as well would involve this guy, red nucleus again. And we knew from last time to get to the red nucleus that we use the superior cerebellar peduncle, so we're going to use that again. And we get into the thalamus in order to get to this primary motor cortex. So again, we're going to use the superior cerebellar peduncle, specifically the ventral lateral nucleus of the thalamus. Okay, now we're projecting from various areas of the neocortex to pontine nuclei. If you remember where pontine nuclei are, it was in the basilar part of the pons. We think back to the corticospinal and corticonuclear tracts coming down. They form bundles in the basilar part of the pons, and the pontine nuclei were there interacting with them and interacting with various areas of the neocortex. And then they were sending fibers through the middle cerebellar peduncle. If you remember the transverse pontine fibers, conveniently located with this guy, the middle cerebellar peduncle, getting to the dentate nucleus, the only visible nucleus in the cerebellum. Visible, I mean to your naked eye. And then from that dentate nucleus, we get into the red nucleus and the ventral lateral nucleus of the thalamus. A disorder of skill movements and motor planning would lead to ataxia, hypotonia, contingent tremor, dysmetria, dysdiadochokinesia, and slurred speech. Okay, and that's just all related to the stuff we learned in skills when they talked about cerebellar disease. Okay, and this is just visualizing where those nuclei are in your cerebellum in coronal section. Fastigial in the midline, and then paravermally, or like next to the midline, would be globose and emboliform, known as interposed. The guy in the DH video did it in threes, so I better number them. Okay, and then the dentate is visible laterally here in those hemispheres, and it's the largest. Okay, and then here is a diagram just showing locations of stuff. Here's your dentate nucleus, the superior, middle, and inferior peduncles, and it just puts things into perspective. Okay, cool. There's afferent pathways. I just included some histological connections here, but specifically I wanted to mention that okay, we're coming from all of these places, right? So from the spinal cord, vestibular nuclei, pontine nuclei, reticular nuclei. All of these guys will use mossy fibers. Okay, they all use mossy fibers. But when we talk about the inferior olivary nucleus, that one wants to use climbing fibers for some reason. And those climbing fibers do a little bit more than mossy fibers. So mossy fibers will just go to the cortex at the granular layer, which is at this like lowest level here. Mossy fibers only reach that part, and they're excitatory. But climbing fibers affect deep nuclei as well. You know, deep nuclei are here in the white matter region. So they affect deep nuclei, and they go all the way up to the molecular layer. Excitatory input to that molecular layer all the way up. So they're going to interact with the dendrites of your Purkinje cells. And then output from the cortex is from Purkinje cells. They project to the nuclei. That's their job. They project to the nuclei. It's just that climbing fibers want to do extra. But the output is inhibitory using GABA. Okay, so yeah, the output of the cortex is Purkinje cells, and that's projecting to deep nuclei. Okay, from there, the efferent pathways from the cerebellum is just going in detail here. I've already summarized that. And we've already spoken about where they're going to in terms of their function. If it's going to go to these guys, it's going to be for balance and equilibrium. If it's going to the red nucleus, specifically tone and posture, it's spinocerebellar. If it's ventrolateral nucleus of the thalamus, it's going to be the neocerebellum trying to do some motor planning, because from there we get to the primary motor cortex. Okay. And here's the diagrams again showing the flow, and this is notes from the DH videos. I spoke about the anterior notch, and then the peduncle of the flocculus is connecting flocculus to nodule. We mentioned that. The tonsils have parasympathetic activity when stimulated, while the anterior lobe has sympathetic activity when stimulated. And then we already know the blood supplies from superior cerebella, anterior and posterior inferior cerebella, which we covered when we were talking about vertebral arteries and basilar artery and the circular willis. And here is a reminder of its functions again. I think it would be a good idea to relate the functions to what each of those lobes do to fulfill those functions. And that's it. Thank you very much.